Hello friends, today we are going to see the electronic suspension control system. So what is the suspension system? Basically the suspension system gives us a feel of comfort whenever the road conditions are irregular. So the job of any car suspension system is to maximize the friction between the tires of the car and the road surface, which in order provides a good steering stability, gives proper handling of the car and gives the passengers a good comfort zone. So if we observe, if the road is completely flat, it has no irregularities, it has no bumps in it, then the suspension system may not play a vital role. But if ever you have observed there are bumps in the road or there are some irregularities, this causes the wheels of the car to move up and down, which get perpendicular to the road surface, thereby causing some discomfort to the driver as well as the passengers. So for this reason we require suspension system. So what is an electronically controlled suspension system? So basically electronic suspension system is nothing but a computer control system which can adjust the ride characteristics and the performance parameters of a vehicle. So as shown here in the block diagram, with the left hand side we have some sensor inputs. On the right hand side we have some outputs which are nothing but actuators, and output of the electronic control unit is again the braking system. So inputs to the suspension system are the yaw rate sensor, a sensor which is used for measuring speed, the steering input, and a sensor which is used to measure the relative displacement of the car. What outputs do we observe from the suspension system are first electrical signals which are provided to the shock absorbers or the motors or the compressor. We have some actuators which act in the form of solenoid switches or motor driven switches, and then we have electrically operated brakes, also called as ABS, or brakes which are used for stability purposes. Here we will see all the sensors in detail. So the first one is the yaw rate sensor. Basically, yaw rate sensor plays a vital role in the stability of the car. So therefore, it measures the vehicle's angular velocity on its vertical axis. So this yaw rate sensor is basically a device that is used to measure the angular velocity or the yaw rate about its vertical axis. This yaw rate is the lateral acceleration of a vehicle which turns at some constant speed. Now this yaw rate sensor is used to provide a relationship between the vehicle speed and the steering input. So if you can see the diagram on the right hand side, now suppose this is a car, four-wheeled car. So the front axial, this is the center of gravity point. The front axial is located somewhere a meters ahead of the center of gravity. The rear axial is located somewhere rear from the center of gravity, somewhere at b meters. Now the body of the car is pointing in the direction theta, but the traveling but while the vehicle is traveling in some direction psi. Ideal case must be theta and psi must go hand in hand. But this is not the case here. So what is happening? The tires are tending to move in the region of contact point in the direction of travel, but the hubs are aligned with the vehicle body, so they are moving as per the steering is held. So the tires get distorted here. They rotate to accommodate the misalignment, and therefore they generate some side force as a consequence, as a problem. So this gives the driver a discomfort, thereby creating some hard feeling for the passengers to move sideways. For this reason, a yaw rate sensor is used. So therefore, to overcome this consequence, to overcome this problem, we have to calculate the stiffness and the damping ratio. So basically, beta is called as the coefficient of stiffness. And why it is used? Now the resultant is because this beta factor has to return zero deflection to the system, which means theta and psi must be equal. Change in speed with respect to stiffness is called as damping ratio. Change in beta, that is change in deflection with respect to the change in speed, that is what is called as stiffness. Now the only satisfactory solution for theta and psi not being equal is that stiffness and damping ratio must be positive, When will these things be positive? When the center of gravity is ahead of the center of wheelbase, that is B is less than A, this will always be positive, and the vehicle's condition will always be stable at all speeds. But if B is greater than A, then the vehicle will be unstable in nature. Therefore, the yaw rate sensor will not work here. Therefore, for every stability purpose, a yaw rate sensor is required. The next input is the steering input. Now the steering input is nothing but a circular wheel that is in the driver's hand, which we know is used to rotate the position of the vehicle to somewhere towards right, left, ahead, or backward. Now this circular motion of the vehicle steering wheel is driven by the one who drives the car, which is nothing but the driver. The main function of the steering system or the steering input is to convert the rotary moment or the rotary motion of the steering wheel, which is in the driver's hand, into some angular turn so that the front wheels move. Now the steering system contains basically a hydraulic booster which operates when the engine is running. Thus, this provides the necessary force when the driver rotates the steering wheel to the right, left, backward, or ahead of the vehicle's motion. So this steering wheel is basically known to all of us. Now we also know for what all purposes the steering input is used. The next we can see is the lateral acceleration sensor. Now these three sensors are at most important for any suspension system. So basically whenever we are designing some automotive or whenever we see some car or there is some manufacturing, we have some norms pre-decided. Now we have an electronic stability control board or electronic stability control unit. Now this unit or this board is used for measurement of safety of a car or any vehicle. Now this ESC is basically a computerized technology which provides the vehicle's stability position. This is done by detecting and reducing the loss of traction or any stress on the road or which comes on the vehicle. Basically, before we move to acceleration, first we need to know what stability is required. So ESCs detect if on a road or if in the path of a vehicle, if the vehicle gets deferred from where the steering is rotated or where the vehicle must move or where the vehicle must head, then ESC comes into picture. Now ESC is basically a sensor system which is used to measure the lateral acceleration that acts on our car in order to calculate its actual position. So the lateral acceleration is nothing but a force that is thrown on the car sideways during a turn. So whenever you are taking a turn, either the driver seeks that somewhere the car is going sideways, either to the right or to the left of where the steering is headed. So there is a bit of discomfort the driver faces. So this discomfort is taken back by using the lateral acceleration sensor. The common unit for lateral acceleration is g-force. Now this lateral acceleration sensor is more often seen when a vehicle corners or when a vehicle is taking a steep turn. This time the vehicle tends to push the vehicle in some another direction, which is also called as sideways. The vehicle is pushed outward. This is because there is some sort of centrifugal force that is acting on it. Thus, the acceleration sensor calculates the force that is acting on the car and it measures the g-force, which is its unit, and then sends this information to the ECU to control the stability of the car. So therefore, every time while taking a turn, the driver always experiences there is some sideways force that is acting on the car. So which sensor does this take care of is the lateral acceleration sensor. So the lateral acceleration sensor will always get the information of the force and how much is the force that is acting, and it will send this information to the to the ECU, which is the stability unit, and then ECU and the stability unit, and they will take those important measures to stabilize the car. Then we have the important unit or the main vital component of a suspension system, also called as the electronic control unit. Now this is nothing but a microprocessor, a microcontroller, or a computerized based system. Now what all inputs, that is the yaw rate sensor, where we have some displacement, where we have a sensor which gives us some sort of displacement or some overspeeding, or the lateral acceleration sensor, or the steering input, where we can get the angular motion or the rotation of the vehicle. All these inputs are basically are in the form of electrical quantity. So these all inputs are first sensed by the sensors, they are sampled, they are converted to the digital format, and then they are stored in the memory, which is located inside the ECU. Now the ECU is going to calculate all these inputs from the sensors, it is going to evaluate all these things, and then we have some standard measurement parameters which are described by the automotive board. So based on it will come based on the standard parameters, it will compare the inputs from the sensors, and accordingly it will set the measurement or evaluation parameters. So it takes into account the speed, the surface of the road, the cornering cases, the stoppages, or the brake, how much amount of brakes you have applied, it will, and the acceleration or the speed of the car, and it will then generate the output electrical signal to various actuators and the braking systems. So the ultimate output of our suspension system are the actuators and the braking system. If in case the lateral acceleration sensor is judged that it has over acceleration, or the speed is very much high, then the electrical signals are sent to the actuators or the braking systems that even though the road roughness is very high and the speed is also very high, there are causes of some accidents, so the braking system comes into picture. So the suspension system is used in this part. So the ultimate output of any suspension system are the shock absorbers, or solenoid motors also, or the braking systems also, or air compressors also. So what does a shock absorber do? Basically, a shock absorber is a mechanical device or an hydraulic device, you can see. It is designed to control the impact of dam shocks and the rebound the moment. So what all the main or the major key role of the shock absorber is to ensure that the vehicle's tire remain in contact with the road surface all the time at all speeds, which is ensuring the driver that you are driving safely. Also, the braking response of the car needs to be taken care of. So the shock absorbers are used to reduce the effect of traveling a vehicle through a rough surface or through a more stiff surface, which leads to a good or better improved quality of the ride and also a proper handling of our vehicle. Basically, shock absorbers work by taking the kinetic energy or the moment of the vehicle from the suspension system, and they convert it into the thermal energy, which is nothing but the heat, and then this whole is dissipated into the atmosphere through a mechanism called as heat exchange. So as you can see the picture here in on the on the right hand side, shock absorbers are basically oil pumps. This is completely a mechanical assembly. So a piston is attached at the end of the piston rod, and they work against the hydraulic fluid in the pressure tube. So there is some sort of hydraulic fluid that is forced to flow through the orifice, or you all can say tiny holes which are inside the piston. Now because the orifice is only allowing a very small amount of fluid to pass through the piston is slowed, which in turn slows down the spring, which in turn reflects the moment of the suspension. So basically this ultimately leads to some absorption of the damp or the shock, and shock absorbers basically automatically adjust the road conditions, because faster the suspension moves, the more is the resistance it is going to provide, and the more is the care car will be taken off, the more safety will be provided, and the comfort zone of the passengers will thereby increase. So what is the ultimate purpose of the suspension system? It must first provide a consistent handling or a proper or a very good handling of our vehicle. The braking system of our car must be excellent. we must the car must be prevented from any premature tire tear and wear. The suspension system must always help in maintenance of the wheel alignment. It must always keep the tires in contact with the road, because on irregular roads, if the tires move up and down, the passengers discomfort is of utmost important. If passengers are experiencing some more discomfort, the car is of no use there, because the safety reduces. So therefore the tires must be in contact with the road. The vehicle's control or the vehicle's bounce or any savvy or roll of the car or the acceleration squat must be controlled by the suspension system. Over acceleration, over speed, over braking, all these systems must be controlled by the suspension system. This suspension system must also reduce the wear on any other vehicle systems. Also, it must always provide a balanced tire and braking work. So when all these things go hand in hand, we can say that the suspension system is perfectly working. Thanks.